to be beginning another subject altogether. We did relations and functions from math, and I would appreciate feedback from you guys on that so I can integrate your feedback into my other videos. Today we are going to be starting with chemistry, right? And although it is not an easy subject, because it is completely concept application based subject, I believe it is a bit easy to prepare because you can kind of predict what kind of questions you're going to be getting into the board, because I'm sure you must have heard it from your teachers by now, but only the NCERT questions come in the board examination. So, lick up your NCERT, eat your NCERT ratta, file it, make it into a mixture in your mixer and drink it up, whatever you want to do, but know your NCERT from each page, each word, every question, you need to know it, right? Then coming up to what chapter we are going to be starting. The first chapter in our syllabus for 2020 to 2023 is solutions. Solid state has been removed, but for those of you who want to study solid state, I will make a video for that later after the board exam, so you can study that for your competitive examinations. Also, for those of you who have had your board practicals and have scored well in it and have done well in the Viva and all the procedures, congratulations. For those who haven't had their board practicals yet, because I'm sure the last deadline was 14 February and a lot of schools might not have had theirs by now. So for those of you who haven't had your board practicals, brush up your projects. No, not brush up, mug up your projects. You need to know every single word that you have written in your projects, because the examiner might ask you any question from any word that you have written in your project. Okay. For my example, my project was on chromatography, and as soon as I said that my project was chromatography, he asked me the principle of chromatography. As soon as I gave the principle of chromatography, he asked me what a mobile phase was, what the stationary phase was. Then from phase he went on to what I meant by a phase. Then after that, all of a sudden he jumped on to organic chemistry, and then he went on to inorganic chemistry. Right, so you need to know every single word that you have written in your projects. So for those of you who have copied off your projects from the internet, don't worry, I have done the same thing. Please learn your projects and read through them once. You need to know all the reactions, all the experiments, all the procedures that you have done in your chemistry lab record. And you need to brush those reactions up, because he might ask them to you. Second thing, mug up your theory. You need to know your theory. It is important. It is as important as the 70 marks paper that you're going to give in the board exam, because even though the practical is of 30 marks, he or she might ask you a question from anywhere. I personally, from my personal experience, I focused more on the lab record part and the project part, and I did not focus as much on the theory part. And he asked me, my examiner asked me a question from the inorganic chemistry about mole fraction and its temperature dependency. Now thankfully, that was one question from solutions chapter that I knew from the many questions that I do know. That was one question I knew, so I answered it perfectly. But had he asked me anything from electrochemistry, anything deep and in detail from electrochemistry or chemical kinetics, I might have fumbled. So please brush up your theory, because he might ask you anything if his the mark goes round and round. Now let us start with solutions. Okay. So before starting any chapter in chemistry, please understand the meaning behind the title, because somehow the NCERT always puts a meaning behind the title that they have given the chapter to, right? So behind solutions there's a meaning. What is a solution? A solution is a homogeneous mixture of two or more, to an extent, chemically non-reacting substances, right? Homogeneous, what is homogeneous? Homogeneous mixture is a mixture where you cannot separate its component physically. Now some of you might ask, salt water is a homogeneous mixture? No, it's not. You can evaporate the water and get the salt out by a physical process. Alloy. Now, alloy is a homogeneous mixture. Two or more metals mushed together, melted and mixed together, that you can't separate physically. Okay, Next, you go on to some more examples of a mixture. Have you ever, you might have done this experiment in your school during 7th or 8th grades, where your teacher might have mixed iron filings and sulfur powder together. Physically, you could have separated that mixture with a magnet, but when you heated it and mixed it, you couldn't separate it, right? That is a homogeneous mixture, and that is one of the best examples I've seen up until now. I have seen up until now of a homogeneous and heterogeneous mixture. That is all about what a solution is. Now, when you talk about the solution, there are two terms that the teachers use very commonly, which is called solute and solvent. And these two terms are very, very important from your board point of view, because every numerical that you have, you will have to identify what the solute in the question is and what the solvent in the question is. And you will have to know what they are for you to identify that. So, a solute is, let's say you have a solution of only two components, right? Now, in that solution, there might be a component that has less concentration in the solution, while there might be a component which has more concentration in the solution. So, the component that has less concentration in the solution, you can call it the solute, and which has more concentration in the solution can be called the solvent. Now, if water is the solvent, then we call that solution an aqueous solution. Coming to water, I am sure in terms of solvent, we have given it a very, very special term. That's right. Water is a universal solvent because it can pretty much dissolve anything in it. Right? That's all about it. Now, again, for those of you who haven't had your practicals, the examiner might ask you a question. What is the difference between dilute solutions and aqueous solutions? Now, dilute solutions, you are only decreasing the component of, you're only decreasing the concentration of the component that is called the solute. So if you're decreasing the component of the solute, concentration of the solute, then that is called dilution. Now dilution can be done with any other chemical substance you add to it, right? That is what a dilute solution is about. And an aqueous solution only contains water and the solute. So if you're adding more water to it and you're making it more dilute, then you can call it an aqueous solution. Dilution by any other chemical substance. Aqueous solutions only water. Right? Moving on. Now, if there is a solution, then there are types of solutions. Right? So, first we can talk about the solvents. Depending on the state of the solvent, there are in total 9 types of solutions. Okay, that's a lot. Now, if the first solvent is gas, or let's begin with solid. That is the basic state we start from. So, let's begin with solid. If the solvent is a solid, then you have a solid in solid solution, you have a solid in liquid solution, you have a, liquid in solid solution, and you have a gas in solid solution. So, for a solid in solid solution, what would be the best example you can think of? Alloys. Metal dissolved in metal, both are solids. That is a solid solution. Now, think about a liquid in solid solution. Hydrated salts, crystallized salts. For example, if you all have done volumetric analysis, I'm sure you have had Mohr salt as your, one of the substances for titration, KMnO4 versus Mohr salt. Now, what is this formula for Mohr salt? It is FeSO4 dot NH4 whole twice SO4 dot 6H2O. This is a liquid in solid solution, right? Dot 6H2O, it denotes that this is a hydrated salt. So this is a liquid in solid solution. Next, if we talk about a gas in solid solutions, then there are dissolved gases and minerals present in the Earth's crust. Okay, so after we talk about this, now we change our solvent to liquid. Now again, depending on this, we have a solid in liquid solution, we have a liquid in liquid solution, and we have a gas in liquid solution. The most basic solid in liquid solution, you can say salt water, NaCl in water, right? The most basic liquid in liquid solution you can say is if you dissolve milk in water. They are two liquids, right? You can dissolve that. And the most easiest solution of a gas in liquid, O2 dissolved in water. what fishes breathe underwater, right? So that is a liquid and solid solution. Again, we change our solvent to gas. There are three types of solutions: a solid and gas solution, a liquid and gas solution, and a gas and gas solution. So for a solid and gas solution, we have let's say iodine vapors in air. When you vaporize iodine, you see those purple fumes, right? Now those purple fumes mixed with air, that is a solid and gas solution. Liquid and gas solution, or gas and liquid solution, you could talk about aerated drinks, soft drinks. I'm sure you all love them, right? And then we talk about gas and gas solution. Air itself is the biggest example of that. It is the biggest homogeneous mixture of gases. So that about sums it up for types of solutions, and then we move on. I talked about dilution and aqueous solutions, decreasing and increasing the concentration. Now, all of this can be expressed in terms of, if you want to express concentration in the solution, there are a lot of ways that you can do that by. The first most basic step is by percentage. Now, you can do mass by mass percentage, mass by volume percentage, or volume by volume percentage. Now, basically what this is for a solid and liquid, we do it by mass or mass by volume, right? So, if we talk about 1 gram of solution in 100 grams of, say grams of solution, 100 grams of solution, then that we can talk about mass by volume, mass by mass percentage. And for mass by volume, we say grams of solute in 100 milliliters of solution. That is mass by volume percentage. And for volume by volume percentage, you again talk about it in terms of volume terms, which is milliliters or liters. That kind of sums it up for our percentage. If we have to write the formula for this, right? So basically, mass of solute upon mass of solution into this basically means solution, okay, into 100. That is our mass by mass. Then mass of solution solute upon volume of solution, sorry. Now this we denote it in grams or kg, however we want it. It depends. And this we denote in milliliters, volume of solution. Again, this denotes solution. This is kind of an abbreviation for solutions. This we denote it in milliliters or liters into 100. Okay, so that is mass by mass percentage, and that is mass by volume percentage. Okay, now moving on to what the strength of a component in the solution is. What is strength? Molecular mass into its molarity. Okay, molecular mass into its molarity. Okay, so for those of you who have had your chemistry practicals, I'm sure you know what strength is because you have done volumetric analysis in your practicals. And in volumetric analysis, you have to find the strength of KMnO4, right? Strength is molecular mass into molarity. That about sums it up of what the strength is. Then we talk about molarity. Molarity ho ya molality, both of these are very, very important from a board point of view because board can give you about 1,000, from 1 to 1,000 questions with with relation to molarity and molality. So molarity and molality are actually two of the most important terms that we have come across in this chapter. You'll know why when we discuss colligative properties and other things as well. So now what is molarity? I'm sure you all know the definition: number of moles of solute divided by the mass of solution in liters or volume of solution in liters. That is molarity. One of the most you can say not favorite, but one of the most recurring questions in the board exam when it comes to reasoning with these two things is which of molarity and molality is temperature dependent. I'll discuss this after I discuss what molality is. Okay, formula for molarity. Molarity is denoted by a capital M. If you don't know that by now, please start studying. Okay, now molarity, capital M, is number of moles Before I go on forward, do you know how to calculate number of moles of a substance? It is basically given mass of the substance which is given to you in the question or which you are using to create the thing upon the molecular mass that you already know of. Okay, so that is how you calculate number of moles. Okay, this is number of moles. I am going to give it the abbreviation N. Number of moles of solute upon volume of solution in liters. That is what molarity is. Coming up to what molality is. Molality is denoted by small m. Again, if you don't know this by now, please start studying. Right? The numerator remains same. Number of moles of solute upon mass of solvent or solution in kg. Now, which one of these two do you think is temperature dependent? I'm giving you time. Think about it. Let's talk about if volume is temperature dependent or not. Now, when you increase the temperature, does the density of a substance increase? It does, right? And if the density increases, then volume is inversely proportional to density, right? So volume of a substance decreases, right? So if that happens, then it means volume is also temperature dependent. And if volume is temperature dependent, then which of these two would be dependent on temperature? Right? Molarity would definitely be dependent because it depends on the volume of solution in liters. Okay, now mass. Mass of a substance remains constant at any temperature. Even if it is 53 degrees in Lucknow, I am not going to change my weight from 72 degree to 78. I am not going to change my weight from 72 kg to 78 kg, am I? Or if you're 50 kgs in Lucknow, which is right now at an average of 20 to 25 degrees Celsius, and I go to Egypt and somehow the temperature over there is too high, so you are not going to weigh 78 kgs over there from 50 kgs, right? Mass does not depend on temperature, so this remains constant. So this it cannot depend on temperature. Molality is temperature independent. Okay. So moving on. This is molarity and molarity. Now, coming back to the question that my examiner asked me in my viva, and that is what is mole fraction. Now, mole fraction is a ratio. It is the ratio of number of moles of the component, like individual component, to the number of moles of solution. So, if it was say a binary solution, now don't ask me what a binary solution is, because binary solution just means there are two components, and I'm sure you know that by now. These are terms that you need to know by now. If you don't, start studying. Now, let's say we have a two-component solution, binary solution, and we denote the number of, let's say it is made of A plus B. Okay, that is our solution. Now, let's say I denote the number of moles of A by Na and the number of moles of B by Nb. So, mole fraction, or you denote it by chi or xi, you call it xi. So, xi A or mole fraction of A would be number of moles of A upon total number of moles of solution, which is Na plus Nb. Similarly, for xi B, it would be Nb upon Na plus Nb. Right? Now, mole fraction is somewhat like probability. So, if it is a two-component solution, you can basically say that xi B also is equals to 1 minus xi A. That's cute, right? It's kind of like probability. It is a ratio, so it has no unit. Oh right, I'm so sorry, I did not discuss all the units for that thing. Now obviously for percentage you will apply the percentage unit. For strength it would be gram per liter, or gram liter inverse. Okay, for molarity it would be mole per liter, or mole liter inverse. Okay, and for molality it would be mole per kg, right? Mole per kg or mole kg inverse. And for mole fraction you have no unit. It's a ratio, it's not supposed to have any unit. Again, now coming back to the temperature dependency of mole fraction, which was asked to me. What do you think? Does it depend on temperature or not? Think about it for a minute. For those of you who are thinking that since mole fraction just depends on number of moles and number of moles only depend on mass, so it should be temperature independent, you're on the right track. That is what the answer is. Okay, so this is also temperature independent. Do not fumble. Okay, let's move on. Right now we have to move on to why. Okay, usually when we deal with questions, or not even with questions, when we deal with daily life, you might see people saying that molality or mole fraction is preferred over molarity, and then the simple reason behind that is again temperature dependency. Molarity and mole fraction do not depend on temperature, so it's easy to use them at any temperature, while molarity depends on temperature, so if we increase the temperature, molarity increases and so on. Right. Tata!